Today we are going to learn about speed, energy, and collisions. To start, pause the video and think about what you already know about energy. It's okay if you don't know anything, that's why we're learning in this lesson. This could include types of energy or the impact energy may have on an object. Unpause the video when you've come up with a few ideas, and check out the Jamboard if you want to contribute or view other responses. On the right, you can see a few examples of forms of energy if you are stuck. We're going to start with a little bit of vocabulary, just so the rest of this lesson makes sense. So energy is the ability to do work. As you can see, there are examples of boiling water or moving a box. Energy transfer is energy moving from one object to another, so like bumper cars or the cars in the video below. Potential energy is stored energy, so this could be like a roller coaster at the top of a hill, or on the image in the right, the ball on the top, the red one. Kinetic energy is the energy of motion, so on the image on the right, this is the ball moving down the hill, or something like a moving car. Now that we've introduced a few vocabulary terms, we're going to use these while we answer some questions. So we're going to watch a quick video, and once we've watched that video, think about these questions. How does the speed of an object impact the energy it has? Did the ball have a higher speed when it started from a higher spot on the track? We have our incline on the left and the point we want our ball to make on the right, marked by the blue ruler. Now if we start the ball lower on the incline where it has less height, doesn't quite make it. But if we start it at the top of the incline where it has more height and might have more potential energy, we see that it does go past the blue ruler. So we're going to do our own experiment. You're going to need a few materials. So you're going to need 2 balls of the same mass. So you could use 2 soccer balls, 2 tennis balls, or anything else you have. You're also going to need an inclined surface. So I used books and a ruler. You can use some blocks and a piece of cardboard to create an incline, or any other ideas that you may have. So for our first experiment, we're going to start by releasing a ball starting at rest from the top of an incline, and you're going to place your hand at the bottom to estimate the final speed of the ball. You're going to repeat this 3 times with a slightly larger initial push each time. As you can see, the ball starts from rest at the top of the incline, and each time I repeat it, I give it a slightly harder push, and I'm feeling how hard it is. I'm estimating the final speed when it hits my hand. So try that yourself and then be prepared for some questions. So does it feel like the ball hit your hand harder as the experiment progressed? And why do you think this is? Consider this and check out the Jamboard if you want to see some other responses, and we're going to move on. We have a second experiment, which is going to be similar. You're going to start with one of the balls at the top of the ramp and another ball of the same mass at the bottom of the ramp. So in each trial, the ball at the top will start at rest, so you're just going to let it roll down. And then in your first trial, ball 2 will also be at rest. In your second trial, ball 2 will have a slight push towards the first ball, so towards the ramp. And in the third trial, it will have a small push away from the ramp. As you can see, it's still starting from rest, and ball 2 is getting a different push each time. Either no push, close to towards the ramp, or away from the ramp. So just some questions for that experiment. How did the speed of ball 1 impact the collision? Remember, ball 1 had a fairly consistent speed each time because it started from rest and picked up speed on the same ramp. And then, how does the speed and direction of ball 2 impact the collision? Ball 2 had a varying speed and direction, so consider that. And check out the Jamboard for some responses. So we're going to have a few discussion questions. Feel free to pause the videos and think about them. And again, it's okay if you don't know. There are plenty of answers available on the Jamboard, and you can always add your own. So what are some other scenarios that could represent the collisions or energy transfer we observed in the second experiment? if you're stuck, think of maybe some games you've played, like bowling or pool, and just think about how the energy transfer was similar, what was similar, and what was different in those scenarios versus what we did in the second experiment. So our final discussion, it would be great if you picked up the Jamboard or opened the tab and looked at some of the other responses for this, added your own. But have you noticed any examples of energy transfer in your everyday life? So this is just a quick starting question. Maybe it's like when you're playing sports or things like that. So now that you've thought of some examples, and again, check out the Jamboard if you can't think of any, try and design a scenario that includes energy transfer in a collision, potential energy, and kinetic energy. So again, think of some sports. You can come back to this video and look at vocabulary if you're stuck, and then add some responses to the Jamboard. So now we have our Scientist of the Week, which is Shirley Ann Jackson. So she was the first African-American woman to earn a PhD at MIT in theoretical elementary particle physics. She was also the chairman of the U.S. Nuclear Regulatory Commission from 1995 to 1999. She was awarded the National Medal of Science in 2016. And most importantly, she's an advocate for increasing diversity in STEM education. So she's a super cool person. And if you want to check out anything more about her, check out the links below, which will also be posted in this video's description. And that's all we have for today. Thank you so much for watching. Again, please check out the Jamboard if you are interested in like a more discussion-based format. And thank you so much for watching, and I hope you enjoyed.